Greeting everyone, this is Amit. Today we are here to discuss current electricity. We will study current electricity layer by layer. What it means, first we will understand the basic concept of current from the chapter, then a little bit more from the next chapter, and a little bit more near to close to BSc and engineering. Why is that? So you can have a clear idea what is exactly current. So if you simply take what we are discussing here, current, in simple fashion it just measures the flow of charge or how much charge has been flown from particular cross section in a given time. That is your current, right? So for instance, let's say if we have a conductor, that's in shape of cylinder, and we'll draw the picture of cylinder in two instants. This is the instant 1, this is instant 2. So we can understand the current from the flow of charge idea. And what current we are discussing here? We are discussing conventional current. There are other types of current also. The current we are going to discuss here is conventional current. So one more thing, current is flow of charge. It is only possible that if charge is flowing, that if it flows from higher voltage to lower voltage. And let's have some section in the conductor like this. This here also. This is section, and here we are representing electrons. And if you pay attention, the electrons in this given section are marked with some particular color. And why is that? I'll show you. Let's say after t time, the picture is this. And from the picture you can see it is at, let's say, time t1, and this is, let's say, time t2. So you can see in dt time, delta t time, there is a change in there is a flow of electron. Why we are taking electron here? Because first we are discussing conventional current. Conventional current is just a flow of electrons in a conductor. So you can see in dt time how many electrons has flown from a given region. This is our given cross section. And if you see the picture, it seems like it is 6, but let's say, because we cannot surely say it is 6, let's say the number of electrons is, and so the total charge flown, which is charge flown in delta t time, can be written as, let's say, n is the number of electrons that has been flown, and E will be charge of each electron. That is flow charge, how much charge has been flowed from this section. Are you getting it? So simply current is how much charge will flow from a particular cross section in a given time. That will be a particular conventional current. Here you can see total charge is coming out to be any. It can be something else also, depending on what case we are taking. So current, similarly, it is not that much difficult to understand how much. It is simply what, if you take a given section, or even you can take a conductor, or you can take a small dB section also. It is just like how much charge will flow from that dB section or particular cross section in a given time. That is your current. And because it measures the rate of flow of charge, so it is just what, coulomb per time That means it is coulomb per second, and which is your 1 ampere. Seems like 1 ampere is forming with from coulomb and second, but you should know 1 ampere itself is fundamental physical quantity. That means 1 ampere is defined, it used to define coulomb and coulomb, not the others. It is a simple depiction of what is current, but if you go a little bit advanced, how to define current? How to define current is simply with the help of magnetic field. How else you can define current? Imagine there is a charge, plus 2 or minus 2, whatever you want to imagine, and imagine this charge is moving. If this charge is moving, and for instance, let's say we near to this charge, we have magnet, north and south. North is formed with the help of blue, red, and south with the help of red. The moment this charge will cross this section or near to the magnet, what you can see, there will be disalignment, or the magnet will show some deflection, which will indicate that magnet has experienced some force. And that's how you can define current, or that's the other way to define current. Means simply what is the current? You can say the phenomena where which causes the disturbance in magnetic field, that is also can be used to define current. Means later on we will study what is the meaning of this statement, but for now you can understand current is also one of the physical quantity which can produce magnetic field. So one way to understand current in basics, it is just the flow of charge per unit time, and if you want to go a little bit more advanced, it is just a physical quantity which can produce magnetic field. That is another way to understand current. Right. So that means if I take conductor, or let's say another example we are taking. So ways in which current can form. So there can be many ways. First is your like very traditional way, like you will have a conductor, there will be, you can say it is connected to some source of potential. Here you will have higher volt, here you will have lower voltage or lower potential, whatever you want to say. So what you will see that current will go from higher to lower, and in contrast of that you will have electron flowing this direction. So you can use let's say if you have that is current free electron density of this conductor that you are going to study in the philosophy concept, but you can also say like if this conductor has some free electron density, let's call it rho, that is free electron density. So how many electrons per unit volume it will have? Free electron is just like dielectron in conduction band. Again we study in semiconductor, which that you can also use to define current. You can take a particular cross section region, and from that cross section region you can have the number of electrons which you can use to find the number of electron and charge, and you can use to define current. So first one is pretty simple one, that is your current in a conductor. Another you can take it like this. Let's take it at atomic level. For example, hydrogen atom. Right. So in hydrogen atom we can also say, like, if you have nucleus, you have nucleus, and around nucleus electron is going to revolve. All that is Niels Bohr's model. It is not the accurate model, but we are using it for some time. You can see the radius will be R. So you can also see, and let's say the time period. The time period is going to be constant. So you can see. So how much charge will flow from a particular section, or you can take any section, how much charge will flow in a given time period? That will be just what? Charge of electron. That also you can use to define current. So total charge flown per unit time will be time period. And if you know the time will be your what, or you can see the velocity is going to be constant, that is what? Distance over time, and you can see time is going to be your and that you can also use to define the current. So what I'm implying that like you just not have the conductor in which you can define current, like conventionally you can have different ways or different ideas in which you can produce current. Although that won't be effective in a circuit most of the time, but still there are plenty of ways you can do it. Right. Another way you can have it, like I'm going to give you this is hammer. You can imagine a pendulum of mass m and charge q. Let the length will be L, and imagine that you are moving it at an angle of theta. So try to find the time period, try to find the current, and we can let's say the time period of it will do oscillation. Let's say the time period is t. Find current at t over 3. You can do it that you can take it as homework. So what I'm saying, that you can have many ways you can calculate current, or you can have the interpretation of current. It is just what a charge has to flow, that will be your current, right? Just like I told you, you can another way of defining current is also magnetic field, that is studying upcoming chapter. Okay. So after all this, let's do okay. After all this, because we are saying current is flow of charge per unit time, that means if charge is also function of time, so if charge is also function of time, means the amount of charge flowing through the conductor is variable, then in that case you can have current as average current also, that will be a del Q over del T, and you can also have your instantaneous current, that is just going to be dq over dt. What does it mean? Means it is just like you are finding the average of instantaneous velocity. I'll explain what is the point of this. Imagine this graph, the graph I want to draw. It is charge as a function of t, or flown charge as a function of t with respect to time graph. And let's say the graph is like this. Right. So how you are finding average current and how you are finding instantaneous current? It is just like, if you are finding instantaneous current, then what you are actually doing, you are drawing the tangent on a graph. All of this is just basics of 11th class, if you remember things. So if you are drawing the tangent, that means your tangent will have point of contact as only one point of contact. That means you are finding the slope of graph at a particular value. Let's call it t1. So this will give you what? theta 1, and that tan theta 1 will be your instantaneous current at that particular time. But if instead of you are drawing tangent, if you draw like secant, means it will have 2 point of contacts. 2 point of contacts. You can see this one and this one. So this will also form some angle with this horizontal axis. Let's call it theta 2, and the time let's call it t2 and t3. So if you calculate tan theta 2, that will give you average current between t2 to t3. So this is about average current and instantaneous current. Average current is just you are finding the secant of the graph, and instantaneous current is just you are finding the tangent of the graph. Both are used depending on what condition we have. Just remember here what you can do. It is just final charge minus initial charge over time, and secondly it is differentiation of charge with respect to time. There is one more way to find the average current. We should know average of any function, not just current, or any function, average of any function. How do you define average of any function? Let's say this is the graph you have, and you want to find the average of a function. Let's call it function fx, and this is function fx. So whenever you are finding the average, you must find average between 2 points. That's how you find the average. Let's say the 2 point is x1. Here the function will be fx1, and let's say the other point is x2. And this is fx2. So what actually you do on finding the average of a function? You find let's say if you want to find the average of a function between x1 to x2. So what you actually do, you calculate the area and divide by the difference between the points where you are finding the average. And how do you find the area? That is just integration of function from x1 to x2 over dx x1 to x2. So you know dx, integration of dx is just going to give you x, and upper limit minus lower limit, it is going to be the same. So what I am making, what it conveying you, that average current can also be found as integration of I dt from t1 to t2 over dt t1 to t2. Alright, we can have an example of this to understand it. For example, imagine a conductor, and let's say I current is going through the conductor, and the rate of flow of charge is given as in first case you have to find current between 2 points, and if you see whenever you have to find average between whenever you have to find anything between 2 points, that means they are simply asking you to find average. So that is your first clue how to find whether they are asking you to find average or instantaneous. If they are asking you to find between 2 points or 2 times, that means it is average. So first question is simply asking you to find average current. And how do you find average current? Delta Q means Q final minus q initial over time. How do you find q final? What time is final in given time? 3 is final. Just put in the equation of time, a charge, and evaluate. This will be your 9 to 18 minus 15 plus 2, that is going to be 5, I guess, 5 coulombs. And initial charge will be at 1, then we can put 1 as a t, and what you will get, this will be your 2 minus 3 minus 1 coulomb. Just substitute in that value, get it from here and put it there. If you paste the values, you will get what? 5 minus 1 over time difference. Time is what? Final 3 minus 1, that is 2. So it is going to be what? 6 over 2, that is 3 ampere. So whenever they have asked you to find current between 2 points or 2 points of time, you should understand that they are asking to find average. And in second point, you can see they are asking to find current at a given point, and that means they are asking to find instantaneous. How do you find instantaneous current? You just do what? Differentiation. If you differentiate, you will get what? Right? That is the equation of current. Whenever you, at whatever time you have to find current, you just put that value of time and you will get the answer, minus 1 ampere, and you can do it. Understood? We can take one more example. For instance, let's take differently. Let's say in this case, if they have given you a conductor in which they have given you current as a function of time. Okay, and let's say they have asked you to find the charge flown in 0 to 2 seconds. Limit can be anything. But if what I'm implying that if in the earlier question they have given you the equation of charge and they ask you to find current, now they have given you the equation of current and then they are asking you to find charge. So if you remember, I is also defined as dq over dt. So whenever you see the current equation, that means you have to use this formula, and from there you can see they are asking you to find charge. You can write it like this, I dt. Then you just do what? Integrate. Where you have to, from 0 to 2. You can assume that initially there is no charge, or you can imagine that initially there is q1 charge. Up to you, or depending on the question. Time is 0 to 2. Now paste the values. And you can integrate. It is not tough to integrate this. Right? Integration of t square will give you tq over 3. 3 and 3 will get cancelled out. You will just have t cube 0 to 2. Integration of t will give you t square by 2. 2 and 2 will get cancelled out. That means you will have just what? T square 0 to 2. And dt integration will give you t, that is 0 to 2. Then upper limit minus lower limit, that is just going to give you 8. And that is going to give you 4. And that is going to give you 4 So you will get 8 coulomb. So what you got? So if you integrate dq, you will get what? Q, upper limit minus lower limit, you will get del q, means charge flown in 0 to 2 seconds is just 8 coulombs. Got it? So if they have given you current equation, you can just simply integrate to get the value of charge. Okay, imagine that in the same question, if they have asked you to find, let's say in the same question they have asked you to find, second part of the question, find average current between 2 to 4 seconds. Then what you will do? There is two ways to do this question. First is you can use this equation and you can write limit 0 to t. Then you will get what? Equation of charge, and then you know final charge minus initial charge, you can get current. Or you can simply do what? You know average current is also found by doing what? Integration of I dt. Same approach, you are just like finding charge, just you have to divide by time difference. What time difference you have? 2 to 4. 2 to 4, and you just integrate, you get the same answer. Right? We already have the integration, so I am not going to do integration again. Just I will write the values and you can simplify. Integration of everything will give you same value, just the limit will be different this time. And this is going to be 4 minus, and you can resolve and you will get the answer. So there is a way to find the average current or instantaneous current, nothing difficult there. Okay, so one more question we will discuss. Let's say okay, so okay, so imagine there is a cylinder of surface charge density sigma. Okay, and let's say they have given you the potential on the surface. They have given you potential at surface. Let's say they have given you 5 kilovolt per centimeter square. Okay, and radius and all is not, let's say it is given, it is, let's say 1 centimeter, and length, let's say it is 10 centimeter. Okay, and imagine this cylinder is moving at a speed of v, which is, let's say 40 meter per second. So what you have here, a cylinder which is hollow, surface charge density is not given, but what else you have? You have the dimensions of cylinder and potential of cylinder at surface. So what has been asked? You have to resolve it for. You have to find current due to the cylinder. So that question, my friend, is going to be your homework question, and you have to complete, and we will discuss this question in next class. Okay.